For more than 1,000 years, people were convinced that the Earth was at the center of the universe. According to the geocentric model, the Sun, Moon, and planets revolved around a stationary Earth. In this video, we will recreate this worldview in the Universe Sandbox simulator and see what the universe looked like through the eyes of ancient astronomers. I will be running a couple of versions of this experiment, and in the first case, I will simply swap the positions of the Earth and the Sun. So what I will do is replace the Sun with the Earth and then replace the Earth with the Sun. I will also make sure to lock the Earth's position in place so that it remains in exactly one spot at all times. And I will also add its natural satellite, the Moon, to the Earth. So here's the Moon. And now I'm starting the simulation, and let's see what happens. The Sun appears to have entered into orbit, but Mercury, however, is heading directly toward it. And the Moon has broken away from the Earth while the Earth remains stationary in the center. Well, in short, the Sun's movement has now commenced, and the planets are starting to follow it. This will essentially cause the destruction of the solar system, well, at least a partial one for sure, but will there be a complete destruction of the system? Well, Jupiter is no longer orbiting the Sun. Venus seems to be moving towards it. Well, you can see for yourselves. In short, the solar system will simply be destroyed. Mars is flying away, Saturn is flying away. If you just swap the Earth and the Sun like this is what will happen. And the Earth simply remained here in the center, and it's pretty clear what happens to it. It started to freeze. Here is a completely icy world. The temperature here has dropped significantly. It's already minus 204 degrees on average. And near the Sun, we see this picture. Mercury has entered a very elongated elliptical orbit around the Sun. And the Moon is also orbiting here, by the way. It's orbiting in the opposite direction to Mercury around the Sun, as you can see. And a number of asteroids from the main belt. As for the planets, well, I can still actually see Ceres, but the major planets in our solar system are indeed no longer in orbit. Only Mercury, which is currently the closest planet to the Sun, remains. The rest, as you can see, is simply flying apart. In the second scenario, I've already created a system where the Earth is stationary at the center of the solar system. Let me show you. So, I'm approaching the center of the solar system, if you can still call it that, or maybe the Earth system, right? As we can see, Earth is right in the very center, the Moon is orbiting it, and here we have Mercury, Venus, and the Sun orbiting in place of the Earth. I'll speed up time, and you'll see that the Sun is actually in orbit around the Earth. So how did I do this, you ask? Well, it took some effort, it was very tricky, but I'll explain it all to you now. Let's take the planet Jupiter, for example. As you can see, its mass and radius are completely accurate to its real characteristics. But to get it to orbit the Earth, yeah, that definitely took some serious effort. First, I just radically reduced its mass in order to get it into orbit around the Earth. Then I restored its original mass. But to keep it in orbit, I also had to go in here and turn off its gravitational pull on other objects. And for Earth, I did the opposite. I made it so that it has the ability to pull other objects, but I turned off its ability to be pulled by other objects. So as you can see, the orbits here are stable. The orbits of Uranus, Neptune, and Pluto haven't fully appeared yet because, well, they move very slowly around the Earth. They're moving at a very low speed because the Earth has a small mass. Now, the closer you get to Earth, the faster things rotate. And in our simulator, time is passing at over 100 years per second. Let's take Saturn's orbit as an example. I'll show you Saturn's motion. It's moving at a speed of only 16 meters per second, which is quite slow compared to what you might expect. That's very slow. Mercury, of course, rotates faster than this, but even here, its speed is still considered low, only 85 meters per second. In a normal solar system, it moves much faster than what we see here. I'll also show you the habitable zone. Here's the situation we get. Since the Earth and the Sun are still at the same distance, 1 astronomical unit, the Earth should have normal conditions, just like in a typical normal solar system. But Mercury, Venus, Mars, and the other planets can receive different temperatures from the star at different times. So what's happening with Earth? Let's take a look. I'll hide the atmosphere and clouds. You see, right now, the planet's northern hemisphere is getting more sunlight. At the same time, the southern hemisphere is getting almost none at all. And a lot of ice has formed here, everything's frozen over. Even the south of Africa and the southern part of South America have frozen. And the average temperature on Earth is slowly dropping. And do you know why that happened? It's because the Earth is stationary in the center while the Sun moves along its orbit at a very slow speed. So by the time the Sun moves to the other side of its orbit to heat the southern hemisphere, our northern hemisphere has had time to get very warm, and the southern hemisphere in turn has gotten very cold. I hope that explanation was clear. I've sped up time to 30 years per second. I had to speed it up a little bit to more clearly show you how the Sun's slow and gradual movement will affect the climate of Earth and the other planets. Yes, the climate might not be calculated perfectly, but you'll still be able to get the general idea. I'm back near Earth. Now watch how the temperature fluctuates as the Sun moves along Earth's old orbit. And as you can see, right now our southern hemisphere is freezing over, while the northern one is completely thawing. and now it's going to be the opposite. See, the north is freezing and the south is thawing. So, basically this is the new change of seasons on Earth. But for this to actually happen, you have to wait an extremely very long time indeed. You can do the math yourselves. 30 years are passing every second. It would probably take hundreds of years for summer to eventually arrive here, for example, in the southern hemisphere, messieurs. The average temperature on Earth, from what I can see, generally fluctuates somewhere between -1 and +6 degrees Celsius. And yeah, you can see how far south the snow reaches. That's pretty serious. Well, I think on a planet like this, the only place you could possibly live normally is on the equator. At least the snow and ice don't reach that far. The probability of life on this Earth fluctuates from 84 to around 90%. You see how different everything is now. And this is exactly how people used to imagine our solar system. And let's take a quick look at Mercury. On Mercury, the temperature fluctuates from around +55 to -51 degrees Celsius. Now for Venus. You can't see the surface at all. Let's take a look at what's on the surface. Well, it's a typical Venus with a molten surface. Let's see how the temperature on Venus fluctuates. The minimum temperature was 174 degrees Celsius. At its closest point to the star, the maximum temperature was over 800 degrees Fahrenheit. Let's also take a look at how Venus heats up with the atmosphere and thick clouds turned on. Well, you couldn't really see just how much the surface actually heated up. Regarding the sun, I'll show you so that you'll believe me. I'll fly over to it. And here basically are its characteristics. As you can see, its mass and radius are completely unchanged, the temperature is unchanged, and the luminosity is also unchanged. In other words, the sun is just a normal sun. It just orbits the Earth. Yes, it sounds incredible. I'll turn on the habitable zone again so you can see in detail how the sun's red and green zones move along the orbits of the other planets. This movement is what actually causes the temperature fluctuations that we observe. For example, when Venus enters the red zone or even gets very close to the black zone, that's the time when it experiences its highest temperature. And it's the same situation for Mars and Mercury at certain times. Of course, Jupiter and Saturn won't be affected as much as the inner planets, but there should still be some slight temperature fluctuation, even if it's not as pronounced. Now you can see Mars. Whoa, look how much it's changed as it approaches the star. For a moment, there was even vegetation. You saw it, right? There was a green stripe, but right now it's -159 degrees Celsius and the temperature is starting to rise again. Now Mars is approaching the star. The temperature reached almost 100 degrees Celsius. Wow, now that's a change of seasons on Mars. Although this part here didn't freeze, it goes from being a completely icy planet to being completely hot. That's incredible. Let's take another look. Here it's approaching the star again, and I'll pause the time. Look how interesting Mars has become with clouds, and there are some bodies of water. Okay, let me fast forward a little bit more. Where's the vegetation? I want to catch the moment when the vegetation appears. A little more. But right now the temperature on Mars is rising. I'll catch it now, guys, definitely. Oh, there, you see. At a certain point, vegetation appears. This means the conditions are right for vegetation. Well, the simulator will immediately display vegetation if the conditions are right in a particular place. So, yeah, something like that. And if we let time run again, Mars freezes over once more. Now you can see Jupiter. I'll speed up time even more. And here I see the temperature doesn't really fluctuate that much, maybe by about 10 degrees higher or lower. The average is around -165 degrees Celsius. Now you can see Saturn. The temperature here indeed fluctuates even less than it does on Jupiter. It's only about 5 degrees higher or lower. And on Uranus, I don't think it will fluctuate much at all. Well, as we can see, it's -219 degrees, and basically, it's not changing anymore. Now you can see Neptune, and the temperature on it has settled at -229 degrees Celsius. And here's the dwarf planet Pluto. On Pluto, it's -238 degrees. Now I'll go back to Earth. I want to go down to its surface here in Australia. And let's look up at the sky to see what the star looks like from here. Here's the sun actually, it's so bright here. I've turned off the space goggles. If I turn on the display, then of course the sun looks just like this. And now, as you can see, we have the night sky. And maybe if we're lucky, we'll see some planets as well. I just saw the moon and it looks very small, but in Universe Sandbox, something's off with the sizes, even though it's at the correct distance from Earth. I've turned on the labels to see where these planets are. Here I see Jupiter, and Venus is nearby, but they're not visible at all. Just the labels simply and clearly indicating which planet is where. You can also quite clearly see where Pluto is from here. Well, I can't seem to find anything else here. So that's what happens if Earth is at the center of the solar system. It was a cool experiment. And if you liked it, please leave a like and write a comment. Thank you very much.